All right, we're continuing the Data Publication 1 workshop, and now we're up to Section 5 in the Table of Contents, Package Management. This will be a relatively brief discussion. We've talked about documenting your data, commenting your code in a literate programming sense, and we move to more subtle levels of reproducibility when we talk about capturing all of the details of our computing environment. And I'm saying package management because I'm thinking about our packages, but this is a more general concept that applies to any computing environment. So it is the case that software changes over time. Software becomes less available over time. And this can, sometimes it's not a big problem, but sometimes it can affect the ability to reproduce the data. When we're talking about working with commercial software and you have produced something in SPSS version 11 and no one can get access to that anymore, they can only use the current version 28 or wherever it is today. There's the expense of using commercial software. Not everyone can get it or reproduce it, but there's also this version issue. Now, open source software has a lot of positives, and I would highly recommend use of open source software, partly for this reason, that there are no barriers to access. Globally, anyone can get a copy, use it in ways that commercial software simply is highly inaccessible in a global environment. And there are repositories of all of the older versions of open source software which are still out there, right? So if there is a version issue and a newer version implements a new method and changes the computations, you can grab that version that you used back when you created the research and prove to people when you run version 1.2 instead of 3.5, you get exactly what I got. And like I said, this is a little bit of an extra level of reproducibility, but it's a good thing to consider. And at a minimum, what I would recommend that you do is when you run your research, record information about your computing environment. There's a command session info in R that will allow you to see your current environment. And I can just run that in the console here. And you can see it just sort of quickly runs and shows the packages that are currently on my system and the settings that I've got, so that we can inform others of what was used for this session. That's a quick and easy thing, just to save that information. And beyond that, there are packages and tools, as there are for any task in R, to help you with this. So renv, or R environment, lets you more easily manage these environmental files and keep them in a specific state, particularly all of the dependencies that your packages are running. And I'm just going to mention these. I'm not going to go into the usage because each one has its own particularities. There is a central repository managed by POSIT that will allow you to access those previous versions of packages. The POSIT package manager, it migrated from a Microsoft tool. Microsoft has lost a little bit of interest in the R space. And this will describe how to use that with the checkpoint package the checkpoint package runs on your system to snapshot your system and allow you to draw the correct versions of the packages. Actually, the tip here says for this, for newer work, you should actually use that renv that we've just mentioned. So renv. Minicran is a way that you can use. This might be useful for larger projects that many people will have this need to spin up a similar environment. There is a way to essentially pull copies. You pull copies of all the packages yourself, and you host them. And if anyone needs to install things there, they grab it from your local repository, ensuring that they're all using that same official version, that everyone is on the same page, so to speak. If we want to go beyond this approach, this is not an R-specific thing. It can be used with any kind of software, but we might want to simply bundle all of our software that we're using for a project into one environment. And this is containerized software. You may be familiar with Docker as the leading exponent of that. That's a commercial version. There's another product called Apptainer, which is a open source version of Docker. So the building of a containerized application is a little bit technical. Your needs may not rise to that level, but it is something that you can do to simply identify all the relevant software, give the containerized environment the instructions to pull all that together into one bundle that someone can then just download the entire bundle and use it. And I should mention also here a third alternative, which is a containerized environment specifically designed for reproducible research data. So this may better fit those specific needs, but if you're also familiar with Docker or familiar with Apptainer, those will work. I'll also say that in section 5.2, code sharing and version control, is that we're in an environment where everything is increasingly cloud-based, collaborative, and part of that is version control, where you're sharing with others your edits and changes and collaborating with people on edits and changes on projects. And you're probably familiar with GitHub. There's also GitLab and Bitbucket, which are operating in that same space. It's good to have alternatives and competition. GitHub is under the Microsoft umbrella. The Git version control software itself is an open source tool, and that will track your changes to any files in a project on your own system. GitHub obviously is and I haven't signed in recently, so I'll just let me go directly to one of my repositories here. So all of the code that I use for these workshops are also hosted on GitHub, so you can, if you prefer, just pull the files from GitHub or clone the repository to get these things. But because this is commonly used now, it is a standard way to share your code, a standard way to make your code visible and reusable by others. So again, I would encourage encourage you to incorporate that in your strategy for informing people of the software tools that you're using. And there are tools in RStudio to specifically link your RStudio edits to a Git environment. From my perspective, I prefer to run those things separately, so I'm not as familiar with them, even as I hunt in the menus for where that is. I know that I have seen it in here. Yeah, here we go. Tools version control. So we'd have to initiate this and start backing up a specific project or a directory that would then allow you to do version control inside RStudio. As I said, I'm used to doing Git on the command line, so I'm not the best exponent of that philosophy. But to conclude this, I would just say, use these tools. Think about ways to share your code in a systematic, automated way. And all of these topics kind of continue in the Data Publication 2 workshop, where we talk about two major things: finding the appropriate repository to share your data. So if you've done all these steps, you've organized your data, cleaned your data, made the cleaning and analysis code available and well commented in Literate programming, and shared information about your computing environment and packages, then you're ready to actually share it and push it out to the world. That is the domain of data archives, data repositories. So Data Publication 2 talks all about that, and also then talks about how to use R to create a package. And packages can be used to share your data and the code that you used to analyze it. So I'd encourage you to turn to those. And I'll stop in this segment. The remaining segment will talk about blogdown and bookdown and Quarto as alternatives for creating larger publications that include data. And then we'll conclude. So thanks again for your attention, and see you in the final segment.